This is the 6th of November, the higher edexcel GCSE maths paper. It is the calculator paper. Question 1. It's a stem and leaf diagram. The answer is basically on your screen now. If you don't know how to do a stem and leaf diagram, these bits down here are your stems and these are the leaves, and they've got to go out in order. You get 2 marks for doing this bit and you get 1 mark for doing the key. There you go. Question 2. It's a scatter graph question. I expect you've got to plot a point. There we go. It says down the bottom, and for another delivery he drives 22 kilometres and it takes 50 minutes. So 22 kilometres and 50 minutes. I've actually plotted that in the wrong place. That should be there. There we go. If you make a mistake, that is perfectly fine, or of course if you're using a pencil you can rub it out. What type of correlation does it show? It's a positive correlation because it's going upwards. If it was going downwards, it will be a negative correlation. On the other side, it says the driver has to drive a distance of 10 kilometres for his next delivery. Estimate the time taken. So you go, do what I've done here. You go to 10 kilometres. You draw up, hit your line of best fit, and you come across. You must draw the line of best fit, and you must draw this line and this line on it. If you do not, you will not get the full marks for it, so make sure you do that. The mark scheme says 20, but if your line of best fit is a bit different and it comes out at say 21 or something, that's fine, but you must put whatever your line points to here. If it pointed at 21 and I put 20, even though the mark scheme says, yeah, that's fine, it would be wrong because you haven't read off your graph correctly. The other question says, during one of the deliveries, the driver was delayed. Which delivery was he delayed for? We need to look for a point that's not where it should be, and this one up here, look, it's quite a short delivery, but it took him ages to do the delivery, so that's the one there. So it took him 45 minutes. That's what it's asking there. Right, next one. Little bit of algebra tucked away in this. I'll just talk you through what I've done. Ali is y years old, so I've said, look, Ali equals y. Barbara is twice as old, so that's why I put 2y. And Keris is 3 years younger than Ali. So if Ali is y, then 3 years younger will be y minus 3. And it says the total of the rate is 125. So y, add 2y, add y, take away 3, is 125. Now you've got yourself an equation, you need to solve it. What I would do first of all is group my y's together. So y, add 2y, add y is 4y, take 3 is 125. You add 3 to both sides to get rid of this negative 3, so 4y is 128. And then divide both sides by 4, so y is 32. So Ali is 32 years old. The person who's 2y is 2 lots of 32, so that's why she's 64. And this person, Keris, is y take away 3, so 32 take away 3 gives you 29 years old. That's the way I do it. There are other ways, but I think that's the most logical one. Question number 4. Okay, there are 18,500 gallons of fuel in a tank. The fuel is pumped from the tank into a plane at a rate of 1,700 litres per minute. You've got a conversion rate there. How many minutes will it take to empty the tank? Just break it down, do lots of different bits and pieces here. So first of all, I'd convert the gallons to litres. So it's 18,500 gallons, and if 1 gallon is 4.5 litres, to go from gallons to litres, you times by 4.5. So that's what I've done there. And it's 83,250 litres. Now it uses up 1,700 litres per minute. So every minute it's using that many litres. So you need to know how many of those go into our 83,250. And to do that you divide, and the answer is 48.97. But it says give your answer to the nearest minute, so that will be 49 minutes. Common mistake here is to divide up the top. Just be really careful when you're converting things like sort of volumes of liquid or currency. If 1 gallon is 4.5 litres, if you've got that many gallons, then the answer is going to have to be bigger than that. Because look, litres is bigger than the number there is bigger than the 1. So your answer needs to be bigger than this number, so you multiply. Question number 5. There's a couple of people who sing in a band, Selena and Zoe. One evening, the band plays for 80 minutes, and Selena sings for 65% of this time. Even before I read on, I'm just going to work out what 65% of 80 is. Because it's a calculator paper, I've done 0.65 times 80, which is 52 minutes. Zoe sings for 5/8 of the time, so I'm just going to work that out here as well. 5/8 of 80, well, you find 1/8 by dividing by 8, and then you times by the top, so you times by 5. So that's 50 minutes. And the question says, Selena sings for more minutes than Zoe. Work out how many more minutes. Well, she sang for 52, she sang for 50, so the difference is 2. So the answer is 2 minutes there. Question number 6, down the bottom. It looks a nice, simple question, this, but it's actually a little bit tricky. A rectangle has an area of 4 meters squared. So what I've done, look, 100 centimeters, that would be 1 meter, if you wrote that on. Let's see if I've got a pencil like that one. So that would be 1 meter, and 400 centimeters would be 4 meters. So there's the rectangle it's talking about. 1 meter by 4 meters, 4 meters squared. But write this area in centimeters squared. So what I've done, 1 meter is 100 centimeters, 4 meters is 400 centimeters. If you multiply them, the answer is 40,000 centimeters squared. A popular answer there is 400, because people think they just times it by 100. But actually, you're timesing it by 100 twice, because it's in 2 dimensions. Question number 7. Here is part of a field. This part of the field is the shape of a trapezium. Okay, well it is. I've drawn that line on, so don't look at that. A farmer wants to put a fence all the way around the outside, so around the perimeter of the field. He has 50 meters of fencing. Does he have enough? Well, the first thing I've done is added up 11, add 10, add 18 to get 39. And now you've got to work out that diagonal slope. You've got to spot that this is a Pythagoras question. And that's why I've drawn that line in there, because then we've got a lovely right-angled triangle. We know the base is 10 meters, so that's 10 meters there. Make sure that's clear there. We know the height is 7 meters, because 18 take away the 11 gives you 7 meters there. So I'm going to put this into Pythagoras. Here's my triangle, I've drawn it there, and here's my workings for it. So a squared and b squared is c squared. Follow it through. C is 12.2 meters squared. So I've added the 12.2 onto the 39 I had for the rest of it, which gave me 51.2 meters. So does he have enough fencing? No, he doesn't. He needs 51.2 meters. Key thing with this question is, look, there's a star next to it. So that means you don't get the right answer for just saying no. It's the quality of your written communication that has been assessed. This is why you need to set it out really clearly like this for this question especially. You really should be doing this for every question. Make the questions as easy as possible for the examiners to mark. Question number 8. It's another starred question, so you expect some good workings on this. Toothpaste is sold in 3 different types of tube. So there's the sizes, and here are the prices. So £1.09p, £1.68, £2.69. Which tube of toothpaste is the best value for money? So I'm going to calculate the cost per 1 millilitre. 50 millilitres is £1.09p. So I do £1.09p divided by 50 millilitres is that much per millilitre. Do £1.68 divided by my 75 millilitres is 2.24 pence per millilitre. And the last one is £2.69 divided by 125, which gives me 2.152 pence per millilitre. So a 125 millilitre tube is the best value for money. There are lots of other ways of doing this. Someone in my class actually worked out what if you wanted to buy 750 millilitres of toothpaste. So I think you'd have to times that one by 6, this one by 10, and that one by 15. Obviously do the same to the price, and you can work it out from there as well. Question number 9. Use ruler and compasses to construct a perpendicular bisector of this line. The perpendicular bisector is a line that goes through it down here. Perpendicular means it hits it at a right angle. So it's sort of the opposite to parallel. So what you need to do is get yourself one of these. If you don't own them, you need to buy them. And what you do, set it up. Doesn't really matter the length as long as it's over halfway. It's a little bit short, that. There we go, over halfway. And put your point at one end and you do a big arch like this. And then you do the same thing from the other side. Put it in there, draw a big arch. Lovely. And where they cross, you need to connect up. So you connect up this point here to this point down here. And there is your perpendicular bisector. That cuts it there at exactly 90 degrees. And you do not rub out these lines. They're called your construction lines. You should leave them in to show that you have used a ruler, pair of compasses. You need to leave those lines on, otherwise I think you've just guessed it. And to be fair, it probably is quite easy to guess, so you need those lines on. Question number 10. It's a bit of a fiddly one, this. A coach travels from Dronston to Lusco. The travel graph for this journey is shown below, right? Question part A. Work out the average speed of the coach in kilometres per hour for the first 10 minutes. Well, the first 10 minutes is up to here. So because we need to work out the average speed, we need our speed, distance, time triangle. So SDT. So it looks like this. Speed is distance divided by time. So speed is 9, because that's the distance, divided by time. And this is where people always go wrong, because they put down the time as 10, but it's 10 minutes. And of course we're going to measure it in kilometres per hour. So you need to work out what fraction of an hour is 10 minutes. And I've just called it 10 over 60. Look, I put it in my calculator like that. And the answer is 54 kilometres per hour. The last bit I'll read out, you've got to finish the graph. So the coach stops in Lusco for 15 minutes. So we got up to here. So if it stops for 15 minutes, think of it this way. This is the distance away from its origin, which was Dronston. So it's not going to move because it's resting. So for 15 minutes, it's going to stay there. And each one of these down here is 5 minutes. So that's why it goes to 15. It stays still for 15 minutes. It then returns home at a constant speed of 42 kilometres per hour. Now I've noticed that it's actually 21 kilometres away. So if it travels at 42 kilometres an hour on the way home, that means in half an hour it can travel half of 42, which is 21 kilometres. So it's going to take you 30 minutes to get home. So it's on 45 there, so you add on 30, you get the 75. So you draw that line coming down. So it's a nice consistent speed on the way home. You get 1 mark for that, doing that bit, and you get 2 marks for getting this bit correct. Next question, question 11. Okay, solve 3x squared equals 147. I mean, some of you might be able to look at this and work it out. What I did is do it in this way. So I need to get x on its own. That's what solve means, work out the value of x. So I've divided both sides by 3 to undo this 3 times. So that gives me x squared is 49. Then I square root both sides to undo the x squared. So x is 7. Work out the value of 2 to the minus 3. Now, because you've got a calculator, all you need to do is to type this in. And I hope you can see this if I zoom in on the screen. So you can go 2 to the power, and it was minus 3. So tap in minus 3 and just press equals, look, and it will say 1 over 8, or it'll also accept 0.125. Any of those answers is fine. Those of you who are quite happy with index laws will be able to do that without a calculator, but if it says do that, put it in your calculator, nice and easy. Next one, simplify this. It says 3x squared to the power 3. So to the power 3 means times itself 3 times. And that's exactly what I've done, look. 3x squared times 3x squared times 3x squared. So do your numbers. 3 times 3 times 3. 3 3s are 9 times 3 is 27. And this is your index laws. When you're multiplying, you add them. So x squared times x squared times x squared is x to the power 6. So it is 27 x to the power 6. Next one, make p the subject of the formula. So here we go. So this is a bit like solving an equation. You want to undo it to get p on its own. So I've added 16 to both sides, so w add 16 is 4p. How do you undo a times by 4? You divide by 4. So that will leave this side as just p, and this side as w add 16 divided by 4, all over 4. And there's a couple marks for that one. There you go. Question 12. Describe the single transformation that maps triangle A onto triangle B. So it goes from here to here. Hopefully you'll look at this and you'll recognise it's a rotation. It can't be a reflection, because otherwise it would be down here and actually be the other way around. It can't be a translation because it's moved around, and it's not an enlargement. So you get 1 mark just for writing rotation. You get another mark for saying how much it's been rotated. You can write 180 degrees or half a turn. Because it is 180 degrees, you do not need to put a direction on it. And you need to find out what point it has been rotated around. Well, it has actually been rotated around the point 2, 1. And if you've got your tracing paper and you put it on there, actually I will go and get some, bear with me. And you get your tracing paper and it will show you how that works. 1 second. Go, all organised. So let's put it on top. We draw around it. There we go, best I can. Put your pencil there, and you turn it around 180 degrees, and it ends up on there. Look, if you don't know where it rotates around, just have a few practice goes. Often it's 0, 0, but you do that, and it ends up in completely the wrong place. Look. So maybe try 1, 1, and just have a bit of trial and error at doing this, right? You will have tracing paper in the exam. If you don't, make sure you ask for it. And after a while, you'll realise it is this point here, which is 2, 1. There you go. And there's your 3rd mark for that question. Don't write just 2, 1. Say around 2, 1 or around point 2, 1. Question 13. Let me zoom in a bit. Given that x and y are integers, right, an integer is a whole number, so 1, 2, 3, 4, 5, 6, 7, and so on. Basically, anything not a decimal. Such that, right, this says x is greater than 3 and less than 7. So the numbers greater than 3 and less than 7 are 4, 5, and 6. This one says y is greater than 4 and less than 9. So there's the numbers that are greater than 4 and less than 9. Find all the possible, and it says, and x and y is 13. Find all the possible values of x. Well, what I've done, let's pretend y is 8 in this case. What add 8 gives you 13? Well, 5. So it could be 5. Let's say it's 7. What adds 7 gives you 13. So where have we gone? So what adds 7 gives you 13? That would be 6. Let's pretend it's 6. If y is 6, you'd need to have a 7 there, but x cannot be 7. So that's why it is only 5 and 6, because you need to add these to these, and it only works with 5 and 6. If you add 4 to 8, look, you don't get a high enough number. Next one is a little bit fiddly, so I'll just leave this here and talk you through it. It says, on the grid below, draw by shading the region identified by the inequalities. Right, basically that there means y is the line y equals -1. So what I've done, look, I've drawn it on and labelled it, y equals -1. This one here, y, call it equals 4 minus x. I've actually done the bits and pieces here. So 4 take away 1 is 3, 4 take 2 is 2, and so on. Then I've plotted this. So y equals 4 minus x is this one down here. And the last one, look, I've just done the same thing, made up some x values, and I've worked out the y values. 3x take away 1, so 3 lots of that is 3 take away 1, and so on. Plot those, and there's that line there, and it is the bit in the middle you need to shade in. So I've marked it with an R, and I've shaded it. That's a little bit fiddly, that one. But if you understand your graphs, you should be able to get it. Question 14. Reverse percentages. Lots of mistakes here. Each year, Wenford Hospital records how long patients wait to be treated in the accident and emergency department. In 2015, patients waited 11% less time than in 2014. In 2015, the average time patients waited was 68%. So what this means is you need to find the number where you take off 11% and you get 68. What everyone always does is they do 68 at 11%, but it doesn't work like that. You've got to find the number you take 11% off. And the way I do it is this: 68 minutes. Now I've said it's 89%. And why I've done that is I'm trying to find out what 100% is. And 100% is going to be my answer, because that's what it was in 2014, 100%. But because in 2015 it's 11% less, that makes 68 minutes 89%. So what I've done then is divided both sides by 89 to get 1%, times by 100, and I ended up with 76.4, and it said to the nearest minute, so it's 76 minutes. So that is reverse percentages. A bit tricky, that one. Next one. The hospital has a target to reduce the average time patients wait to be treated in the A&E department to 60 minutes in 2016. Work out the percentage decrease the hospital is going to need. So it takes 68 minutes at the moment, and you want to work out what percentage. Okay, to do this, you do the percentage, the amount you want it to go down by, which is 8 minutes, because you need to get it down to 60 minutes, over the 68 minutes, and you times that by 100, and it gives you that percent, and I've rounded it, look, to one decimal place. So 11.8% is how much it has to fall. I guess you could do that by trial and error, but this way is much quicker. Question 15. Right, here we go. Whoa, what a horrible looking question. Right, B, C and D are points on the circumference. B, C and D, there we go. BOD is the diameter, lovely, it goes to the middle, yep. Explain why angle BCD, so BCD is 90 degrees. Okay, a couple of things here. A triangle inside a circle with a diameter as one of its sides, so that's one of its sides there, will always make a right angle with the circumference if it makes a triangle. For those of you who know your circle theorems, it's actually called the alternate angle theorem. Well, the alternate angle theorem is that this one here is equal to this one here. So there's two things you can say. You can say that if one of the sides is the diameter, then if it makes a triangle, it's always a right angle, or the alternate angle theorem. So that one is the same as that one. Next one, calculate the length of BC. Right, a few things you need to do first. First of all, I'm going to calculate this length here, B to O. So what I've done, I've drawn the mini triangle I've got down here for it. So calculating B to O, it's your trigonometry. So long sides hypotenuse, opposite the angles, the opposite are the ones the adjacent. So I'm interested in these two here. So it's some old hags. So sin 35 equals opposite over hypotenuse. So it's x over 7. Bit of rearranging, you want to get x on its own. So you multiply both sides by 7. So 7 times sin or sine 35 equals x. So x is 4.015. Let's go back to the top. If that is 4.015, I can then, to find the whole length of this, I can double it, because that there is the radius. So if I double it, look, I get 8.03. So now I'm going to look at this triangle here. It's got 70 degrees, a right angle, and that would be 8.03. 70 degrees, right angle, 8.03. Let me zoom in for you. And I had to calculate angle BC, which was this one here. It's actually the adjacent. So I've labelled my sides. Hypotenuse is a long one. There's the opposite, there's the adjacent. So I know the hypotenuse and I want to work out the adjacent. So that carries a huge. So it's cos 70 equals adjacent, which is x, I don't know it, over hypotenuse. Same thing there, do your workings, divide both sides by 8.03, do the calculation, and you get your answer, which is 2.7464. And it says round it to 3 significant figures, so that is 2.75 to three significant figures. Question number 16. Write this in standard form. Standard form has got to be a number between 1 and 9.9 times 100 to the power x. If you know your standard form, the number between 1 and 9.9 is going to be 6.4 times 10 to the power. How many places do you move the decimal point? Well, it's going to be 8. So 6.4 times 10 to the power 8. Next one. Work out 3 times 10 to the 7 divided by 6 times 10 to the 4. Right, you can either do this on your calculator. It might not give it to you in standard form. We don't actually need your calculator for this one. Okay, question 17. L1 and L2 are parallel lines. The equation of L1 is 3x plus 2, and L passes through the point 3,4. Find the equation for L2. Right. Because they're parallel, that means they're like train tracks. They go on forever. The gradient must be the same. So and the gradient will be this m bit here. That stands for gradient. So I'm quite happy to write y equals 3x, and you'll get 1 mark for doing that bit. Then you need to work out where it's going to cross the y-axis. And to do this, I've done a little bit of substitution. Your x value will be 3 and your y value will be 4. So if it's 3x, so 3 times 3 is 9. The y value is 4, look. So 4 equals 9 add what? And it's actually minus 5. So that's why y equals 3x minus 5. So you've got to substitute in your values for where L2 crosses through the point on the graph. Right, moving on, question 18. This is a box plot, a couple of easy marks here. Write down the median. The median is that one there, so that is 37. The interquartile range, that is the upper quartile, which is 71. Take away the lower quartile, which is 35, which is 36. Nice and simple there for 3 marks. You should be getting all of those. Right, the next one says compare the two distributions. So compare, this comes up quite a lot. What you need to do for your 2 marks is to compare the median average, and you're given the median average here, and you've got it written down here. By the way, this is all about countries competing in the Winter Olympics at the top and Summer Olympics down here. According to the median average, more countries compete in the Summer Olympics, which is 121 compared to 37. You get 1 mark for that. And the number of, my second comment for my second mark is the number of countries competing in the Winter Olympics is more consistent, and a measure of consistency is the interquartile range, because the interquartile range for the Winter Olympics is 36, and for the Summer Olympics, I've worked it out here, it is 116. So this one is more consistent, and that's for the Winter Olympics. So you can say that. Question 19. Right, this is a bounds question. The value of P is that, and Q is that, and then to the nearest 1 decimal, or to the nearest 0.1, write down the lower bound for P. That means what's the lowest this can go, but you round up to 4.3, and it will be 4.25, because obviously there's nothing lower than this that you would round up, because 4.24 you'd round down to 4.2, so it's 4.25. Work out the upper bound for R. So we've got a little formula here, right? R equals P add 1 over Q. So first thing we've got to do is we want the upper bound for R. So we need to make R as big as possible. So I'm going to make P as big as possible. So that's the lower bound for P. So the upper bound for P is going to be 4.35. Now, I know some of you might be sat there thinking, well, 4.35, wouldn't that round up to 4.4? Well, yes, it would. You're correct. But if we don't write that, then we'll have to write 4.349 reoccurring. And you could argue that anything reoccurring, like 9, for example, actually rounds it up anyway. So we use 4.35. If you want to go and do A-level, you've learned more about that. It's fascinating stuff, actually. So I forgot what I was doing now. So that's the upper bound for P. 4.35. Right, you need to make 1 divided by q as big as possible. So we want as many of these q's to go into 1 as possible. That's what dividing is. So I found the lower bound for q, and it is 0.35. So I've done 4.35, which is my high value for p, add, because you're adding, 1 divided by 0.35, the lower bound, and that gives me 7.207 reoccurring. 3 marks for that. There's sort of question, if you get them, you get them. If you don't get them, you don't quite get them. But you can always easily pick up some marks along the way. Okay, question 20. Here are 2 watch faces, A and B. They've both got a radius of 2 centimetres, and the material to make both watch faces has the same thickness. This one's made of plastic, this one's made of plastic, and that little bit of 20 degrees in there is metal. The ratio of the cost between the metal to the plastic is a ratio of 3 to 2. So let's just start off. What I've done, the area of both faces, area is pi times the radius squared, so pi times 2 squared, so that's 8 pi. And I've left it at pi, and you'll see why in a minute. By the way, you get a mark for doing that, so even if you're not sure about it, you get a mark for working out the area. The face B, now this is where it gets a little bit tricky. So I've done 8 pi, because I'm going to try and work out the cost of that metal bit compared to the plastic. So it's 8 pi, which is the area of this. Now I've divided by 36, so that means splitting up into 36 equal bits, as if each bit would be 10 degrees. Okay? Then you times it by 2, because that's how many sets you've got here. If it's all split into 10 degrees, times it by 2. You times it by 3, because that's in the ratio, that's the cost of the metal, and that will give you 2/3 pi. Now that's the cost of the metal for it. Now we're going to work out the cost of the plastic. So similar thing, you do 8 pi, which is the area, divided by 36, times it by this time 34, which is the rest of it, and I'm timesing it by 2 because it's the plastic one, which is the 2-bit, and that gives me 68 over 9 pi. You add those 2 up and you get 74 over 9 pi. So I've got here the plastic watch and the metal watch. The plastic one is just 8 pi because it's a simple one, it's all plastic, and the metal one is that. So I've written it as a ratio, but that's not quite good enough. First thing I do is cancel pi from both sides, so I've got 8 to 74 over 9. I want to get the denominators the same, so this takes a bit of a leap of faith, but I've converted 8 to 72 over 9, because that 72 divided by 9 is still 8, isn't it? And that one stayed the same. Then I can cancel the 9s, so I've got 72 to 74, and because it says give it in its simplest form, you've got to half those two, so it's 36 to 37. Nasty one. Question 21. 148 students went to Brighton. Each student went to the aquarium, or went to these places, and here's the information. The teacher takes a sample of 40 students, and it is stratified by gender and place visited. If you don't know stratified, pester your maths teacher about it, because it's dead easy to learn, and look, it's 2 marks. Work out the number of students in the sample who were female and went to Brighton Wheel. Female Brighton Wheel is 35. So what you do 35 divided by the whole lot, add them up, and you times it by the number of students you're going to take in your sample. So that is 40. And that will give you, well, that's written there, and that rounds, well, I think you can't, that's not an acceptable answer, I don't think, so you can't have 0.459 of a student, so I've rounded it to the nearest number, which is 9 students. That is fine. Right, question 22. Alison is using the quadratic formula. By the way, this is written at the front of the exam paper, so if you don't remember it, have a look for it. To solve a quadratic equation. She substitutes the values into the formula and correctly gets that. Right, so she started off with this, and she substituted in the values of A, B and C, and it gives her this. And what the question is asking is, what are the values of A, B and C? Well, if you've got your formula here, we can have a look, can't we? So A is 2, because in the formula it's 2 lots of A. So basically 2 times what gives you 4. Well, there you go, it's got to be 2, because 2A is 4. B is 7, because B squared is 49, so B must be 7. and C is 4, because you need to do a little bit of substitution here for this bit. This bit here is 32, so you do 4 times A, which we said was 4, so that's 16, and sorry about that. Hang on, go back to part C. C is 4 because 4AC is 32. Right. So so it's 4 times A. A is 2. So that's 4 8s. 4 2s are 8. 8 times what gives you the 32? It's 4. So and you need to put it in that form now. So it is 2x squared, add 7x, add 4 in that format there. I suppose you could argue you should even write equals 0 at the end. But there's your answer for that one. Okay, question 23, last few coming up now. This is transformations of graphs. I'll quickly go over these because you either know them or you don't. So here's the graph for y equals sine x from minus 180 to 180. On the grid above, sketch the graph of y equals sine x, add 2. Right, if you're adding 2, what you need to do is move it up twice, all the way. So that's what I've done, and that's what you should have. If you're not sure about that one, you can just have a guess. And for the one down here, this is a lot trickier, this one. This is a graph of y equals cos x. And it says, on the grid above, sketch the graph of y equals 2 cos x. Oh, sorry, minus 2 cos x, very important. Right, the minus, first of all, flips it upside down. So if you can imagine the whole graph sort of being reflected, you'll do that. But the 2 actually stretches it out as well. So you've flipped it and you've stretched it twice, which is why it ends up like that. Question 24. ABC is a triangle. Work out the length of AB. So that's this length down here. Right, first thing I'm going to do is calculate side A, because we're told the area is 100 meters squared. So this is a formula on the front of our exam paper. Area equals a half AB sine C, sorry. So I've substituted the values in. So a half A, we don't know what A is, look. B is the side opposite B, so it's 8.4, and sine C is sine 40. So what I've done, I've multiplied both sides by 2 to get rid of that half, because it was bugging me, so that becomes 200. I've then divided, I want to get A on its own, so I've divided by 8.4 times sine 40, which gives you 200 over 8.4 times sine 40 equals A. So that means side A is 37.04. So that is 37.04. Now, you probably get a couple of marks for that. The next bit, you've got to almost redo it, and you've got to relabel it, because we're going to calculate A, B here. And what I've done is actually have to fiddle around with the letters, because it won't, this rule here won't work with the letters they are, so you've got to change them. So I've redrawn the triangle, and we're actually going to be working out BC for this one here. But it's the same triangle, look. All right, so A squared equals B squared as C squared. Take away 2BC times cos A. That is in the front of your exam book. If you haven't seen them, I suggest you take a look. That is there, and it is the cosine rule on the front page. Right, here we go. This is what we do. Substitute your numbers in. So we're trying to work out A here, look, and A is opposite the angle A. So well, I'll let you have a look at it if you like. I could talk you through it, but I guess I'll just be chatting over numbers. This is, when you get to this stage, it's mostly a substitution part of the question. If there's any bits and pieces you're not entirely sure of, you can just double check, but I think it should be fairly self-explanatory. And it says give the answer to 3 significant figures, so 31.1, because the 7 rounds it up. And we're on the last one here. This is a probability tree diagram. Let's quickly read the question. 30 sweets, 18 fruit, 7 aniseed, and some mint ones. I'm going to take 2 sweets at random, work out the probability that they will not be the same type. I'm going to go through this fairly quickly. You need to know what probability tree diagram is and what it does. So here, look, you've got fruit, aniseed, and mint, and I put my probabilities in here. So it's 18 over 30, and so on. The key thing here, and I'm just going to zoom in on this top bit and just explain this, because some people get this bit wrong. She's going to take another sweet. And if she takes another sweet out, the probabilities are going to change, because there's no longer 30 in there, there's only 29 in there. So if she takes a fruit one first, that means there's only 17 fruit ones left. If she takes the fruit one first, there's still 7 of the aniseed ones, and if she takes the fruit one first, there's still 5 of the mint ones. And you've got to apply that same principle to that bit and that bit. The question says work out the probability that they're not the same type. So I've gone down and worked out the ones that aren't the same. So fruit, aniseed, fruit, mint, aniseed, fruit, aniseed, mint, mint, fruit, mint, aniseed. So I've avoided the other 3 there. You calculate across, so this one here is going to be 18 over 30 times 7 over 29, it's 126 over 870. Do that for the ones we want to do where they're different, and then you need to add them up, and you get 502 over 870. The mark scheme says that. I don't see anything wrong with you simplifying it, to be honest with you, but it doesn't say to, so either one of those answers would be fine. I guess if you do simplify it, say you have simplified it. Another way of doing it, some of you will spot this, is to work out the ones that are the same. It's probably a bit quicker this way, and then just subtract from 1. But for the purpose of trying to explain it, I've worked it out this way. I hope that makes sense to you. I'll put some grade boundaries up. I hope you did well. Thank you for watching.